Hello everyone, my name is Zaidman and today we are going to take a look at OKD on top of oVirt. Before we get started, a little bit about me. I'm a senior software engineer working at Reddit for the past 3.5 years now. Currently, I'm the team lead of the OpenShift on top of Rev effort. In the past, I worked on other oVirt projects such as the Virtual WinDriver installer and Python 2 to Python 3 porting effort. You can find out much more by taking a look at the LinkedIn or GitHub accounts. So what are we going to talk about today? First of all, we'll get to know OKD a bit. What is OKD and what are the main features that it provides? Then we are going to see why do we even want to install OKD on top of our existing oVirt instance. And last but not least, we're going to see a demo. So what is OKD? I hope that you are familiar with Red Hat OpenShift and Kubernetes before this talk, and if not, that's okay. There are many great materials online that you can find out with a simple Google search. But that's not going to be the main point of this talk. We are going to focus on OKD itself, and more specifically, OKD on oVirt. So OKD is a sibling Kubernetes distribution to Red Hat OpenShift. It's essentially the upstream of OpenShift in the sense that it is open source, currently available to download right after this presentation, and completely free. OKD is an open source distribution of Kubernetes. It adds many features on top of it that we are going to review in this talk. OKD can be installed on many environments, such as cloud environments, virtualization platforms like oVirt, for example, or even bare metals. Now let's take a look at a couple of OKD main features. There are more features, and we're not going to dive too deep into each feature, but I did add a short slide on each feature in case you're interested and want to take a look after this presentation. So OKD provides high availability, whether it's for your cluster or the components that compose the cluster, or it's your user applications that you're running on top of OKD. It uses a lightweight operating system, which is Fedora CoreOS. It provides internal load balancing inside the cluster or external load balancing if you're using a cloud provider. As you know, oVirt does not provide an external load balancer. It has auto-scaling capabilities, whether it's the pods or applications running inside OKD with the Kubernetes autoscaler, and worker nodes autoscaling via the machine API. Essentially, what that means is that the cluster can increase or decrease the amount of VMs that are provisioned at any given time based on the load the cluster is experiencing. It adds logging and monitoring, service discovery, application management, cluster extensibility via operators, whether it's operators managed by the operator lifecycle manager or the operator hub, which you can install after the cluster is installed. And last but not least, we provide storage integration via the oVirt CSI driver and operator. Basically, you can create Kubernetes persistent volumes, which are oVirt disks in our case, that are available for your applications. So, why would we want to install OKD on top of oVirt? First of all, we support multiple installation methods. We have the installer provisioned installation, which is very opinionated based on best practices, but it is extremely easy. We do allow you to customize that installation a bit, whether it's customizations on the workers or master nodes or on the entire OKD cluster that will be created, but it's not as customizable as creating your own infrastructure. For that case, we have the UPI installation, which is a user provisioned installation. It's a lot of manual work, but sometimes it pays off in case you need it. Or we have IPI or UPI. As I said, IPI is very opinionated. It is based on best practices, for your OKD cluster. The installer will create everything that is needed to run OKD on top of oVirt. It will create the oVirt VMs. It will create affinity groups if you configure it to create affinity groups, oVirt disk, oVirt tags, and everything that is required on your existing oVirt environment. We do allow some customizations to be done, and of course, everything is very clearly documented in the docs. And we have the user provisioned infrastructure. UPI installation is done completely by the oVirt administrator. The oVirt administrator will create all the VMs and everything that is required to run the OKD cluster. It is very customizable, but it comes with the price of actually maintaining it and performing the installation. There are a set of Ansible scripts that are available in the documentation, which you can use to deploy your user provisioned infrastructure. Currently, we only document creating the OKD cluster without platform integration. Essentially, what that means is that there is no machine management, scaling or auto-scaling of worker nodes, and no CSI support at all. We do intend to change it in the next version and hope to have documentation for user provisioned infrastructure with provider integration, but currently there is none. Another reason to install OKD on top of oVirt is the ease of maintenance. Basically, maintaining oVirt VMs is much easier than maintaining bare metals, especially when it comes to OpenShift. Plus, the oVirt provider allows us to manage the OKD machine lifecycle from OKD itself, whether it's the CLI or UI. But the user doesn't have to be an oVirt admin, and it doesn't have to go through the oVirt UI for creating new VMs, for example. Plus, as I already mentioned, we support scaling and auto-scaling of oVirt VMs, something that is not possible if you're doing a bare metal installation. Basically, what that means is that you can create or destroy oVirt VMs from OKD. Or if you're using the autoscaler, the cluster itself can create or destroy oVirt VMs depending on the load that it is experiencing right now. Of course, that everything is done through customization, and you can define rules of when to create new VMs and when to destroy them. Another good reason is the support of mixed environment. oVirt currently is the only provider of OKD that supports mixed environment, meaning having some worker nodes that are oVirt VMs and some worker nodes that are actually just bare metals. So you can have your control plane running on top of oVirt, some worker nodes as VMs, and some worker nodes as bare metals. Another good reason of using a virtualized provider is that you can take advantage of virtualization features, such as, for example, resource overcommitment. That is mostly recommended for dev or test environments, but in case you have an oVirt cluster that is not big enough to hold an entire OKD cluster, you can use memory overcommitment to create and test that cluster. And of course, you have thin or thick provisioning in case you don't have enough storage, and basically all the great features that oVirt provide. And last but not least, you can fully utilize your hardware. When you're doing a bare metal installation, it doesn't matter how much memory or CPU your bare metal have, it will always be one worker or one master. When you're using a virtualization provider such as oVirt, you can split that very powerful host or a set of hosts into an OKD cluster. Okay, now let's see how to install OKD on top of oVirt. The first thing we need to make sure is that we meet all the specified prerequisites that are actually needed to install OKD on top of oVirt. So I linked here a doc with all the prerequisites needed. Go over it, make sure that that your oVirt environment actually meet those prerequisites. One of the prerequisites is having 2 static IP addresses for the API and ingress virtual IPs. That's something that we need to prepare in advance. And last but not least, something that is very specific to OKD, we need a pretty long DHCP list time. I recommend above 30 minutes. I use 1 hour actually in my dev. And a quick note, currently 4.9 release doesn't work on oVirt and actually any virtualized platform because of an FCOS issue that is under investigation. So in this demo, we will install 4.8. So this is the OKD site. Scroll down and go to getting started. And we will go to the OKD GitHub. And first thing that we need to make sure is that we download the OC client and kubectl client. If you already have them installed, you can basically skip on that step. So here we are getting them. We will extract the tar and move the 2 executables to /user/bin. Okay, now that we have the client and we see that it is working, we will proceed to extract the OpenShift install binary. So we will close the releases and we will add on to the nightlist page. We need to use the nightlist page because currently, as I noted, we only support 4.8 and 4.7 is not yet installed regularly on the oVirt, and 4.9 is broken. So I recommend to use 4.8. Here we use the OpenShift client to extract the installer from the release. Once this process is done, we will get our OpenShift install binary that we can use and actually an updated client. If you remember before, we used the client from the stable branch, which is 4.7. It actually doesn't really matter that much if you're using a client which completely correlates with the installer version, but it is recommended. So we have the OpenShift install and the OpenShift client tars. We will extract both of them. After we updated the kubectl and OC, we can run the OpenShift install command. First of all, let's see what we have on create. So essentially, there are 4 targets. There is the create cluster, which completely creates the entire OpenShift cluster by using the user questions without any customizations. There is the ignition configs, which allows you to edit the machine ignition files before running the installation. This is only recommended for advanced users. And there's the install config command, which allows us to use customizations. Basically, we first create the install config YAML, then we can customize the install config, and only after that we can actually install the cluster. So that's what we will do now because I want to customize the installation a bit. So we run OpenShift install create install config, and we answer all the user questions. We select oVirt as a platform, enter the engine FQDN. Port is optional in case you need it. We specify that we want to trust the above certificate. Enter the username, which is by default admin at internal. The engine password. Select the oVirt cluster on which we want to install OKD. Then the oVirt network which you want to use. And the 2 virtual IPs that we defined before we even started the installation. Those are listed in the prerequisites. Afterwards, we enter the base domain and the cluster name. Both those fields are in the documentation. And lastly, we specify the pool secret. because OKD is completely open source and completely free, there is a fake pull secret for the installer to actually ignore. Now let's customize the installation a bit. So we have a section on compute, which are the worker nodes. We have a section on the control plane, which are the masters. And we have a section for the entire platform, for the entire installer. The platform section contains all the parts that are specific to the entire cluster. For example, which storage domain to use, which oVirt network to use, affinity groups that the installer will create, and so on. All the fields that are customizable are actually documented in the official documentation of OpenShift and the OKD latest documentation. I'll just change the workers to deploy the installation to deploy 2 workers instead of 3, just because my env lacks the resources. And now that we have edited the install config, we can actually create the cluster. Before that, I want to show you something that you might need to use, which is the wait for command. Wait for is used in case the installation didn't complete successfully, but you want to give it a couple of more minutes to keep on trying, basically. So you have the wait for bootstrap to complete and wait for install to complete. The bootstrap is the initial phase of the installation. That phase exists until the bootstrap VM exists. And after the bootstrap VM is deleted, you have the install complete, which is successful only once the cluster is stable. Because we are using OKD, sometimes the installation will not finish in time and we will need to wait for it to complete. In case that is the case on your end, I don't know which lab you're using, if your network is strong enough and so on, then you have to wait for, and you can use it to wait for the installation to complete and actually make sure that the installation is complete before starting anything. Now let's create a cluster. After we issue the create cluster command, the installer will begin working. Okay, so if everything went smoothly and the installation was successful, this is essentially the output you will see, although this is a debug output. Basically, what you will see here is the link to the OKD console, the username and password for you to log into, and also the path to the kube config you can export. This essentially saves you the time of logging into OC as a kube admin from the CLI. Both are kind of equivalent. Let's take a look at the oVirt engine to see what was created by the installer. In my engine, I currently have 2 clusters running in parallel, oVirt 11 and oVirt 10. oVirt 10 is the new cluster that we just installed. If you remember, when we answered the user questions, we set oVirt 10 as the name of the cluster. So I have here 3 masters and 2 workers like I configured in the install config. Each has its own IP address and the time has been up. Now let's take a look at the OKD UI and log into it. We'll fill in the username and password that we've got when the installation finished. And we are inside OKD. This is basically the administrator UI of OKD. There's also a developer view. You can see all the details of the clusters. And we take a look at pods. Because we are on all projects, we will see here all the pods that compose the cluster. So there are stuff like API server and so on. If you'll filter out by project, You can look into your own predefined namespaces or a specific cluster namespace. Here we have the node. As you can see, each of the VMs we just saw on oVirt has a correlating node to it, and each of those nodes has a correlating machine to it. This is just how OKD or OpenShift works. You can see they are all listed as provisioned as a node, and on the machine set, which manages only the worker nodes, we have 2 machines because we have 2 workers. Now we can scale the machine set up and create a new worker. You see that I have 2 out of 3 machines, and I have 1 worker node which is on provisioning state. It takes some time for a node to be created from the machine, basically around 10 minutes, all depending on your infrastructure, of course. As you can see, a worker was created and soon it will be started. Now that we have seen an OKD installation on top of oVirt and even a manual machine scaling, we can take a look at the autoscaler feature. So as we saw in the previous demo, this is my environment. I have here 3 masters and 2 workers. And also on OKD, I have the same amount of masters and workers. Created a couple of YAMLs in advance, which are the cluster autoscaler and the machine autoscaler. You can basically follow the documentation that I linked in the slides and create your own depending on your needs. All the different configurable fields are detailed there. Now I'll create a cluster autoscaler, and I'll just check that it was created. And now I'll create the machine autoscaler. My envelope does not have enough resources to contain 6 machine replicas, so I'll just edit that to 3. And I'll create a machine autoscaler. I'll just check that it was created successfully. And as you can see, I have a minimum of 1 worker and a maximum of 3 workers. And it manages a specific machine set, which was created by the installation. Here's the deployment that we are going to create. Just a scale-up deployment. It does nothing but requests a lot of memory. And it has 20 replicas. So it essentially creates 20 pods, each requesting 2 gigs of memory. My 2 workers can contain all those pods, so a new worker will need to be created. Now, when I'll create the deployment, you will see that a new worker will be provisioned. As you can see on the OKD console window, a new worker was already created, and soon it will also appear on oVirt. Now we can see that the new worker is spawning. It will take that worker around 10 minutes on my lab at least to become a prepared and ready node. When it will become ready, other pods will be scheduled on it. Okay, everyone, that was it for our demos. We saw an OKD installation from scratch, a manual machine scaling, and machine scaled via the autoscaler. Thanks everyone for joining us, and feel free to contact us on Slack, email, or even on the GitHub project itself. Thanks everyone.